Elon Musk recently made a surprising announcement that has sent shockwaves across the aviation world. SpaceX, in partnership with the United States Air Force, has recently unveiled a $4 billion aircraft that promises to transform the sky. This game-changing aircraft, equipped with cutting-edge technology and capabilities unlike any seen before, is poised to change the future of air superiority. What are the new jet's capabilities? What are the parallels between Elon's new aircraft and the United States' sixth-generation aircraft? Join us as we reveal the $4 billion sixth-generation aircraft that Elon Musk has unveiled for the globe. SpaceX has quietly purchased a new Boeing 737-800 and painted it with a striking gray and black appearance. It's unclear what the corporation intends to accomplish with this aircraft. However, it might be employed as a business shuttle testing platform, or both. The distinctive paint job and potential use have prompted similarities to some of the world's most clandestine 737S models. Boeing began work on the narrow-body 737 in the early 1960s. They aimed to create a jet that could be operated alongside the Boeing 727. The 737 was designed for shorter flights, while the 727 was designed for longer distances. However, the 737 proved extremely successful in the airline business, eventually replacing the 727. Lufthansa acquired the first 737, and production began in 1986. Since then, around 12 Boeing 737s have been built, and Boeing is still producing the most recent variant, the 737 MAX. There are also almost 5,000 additional 737s on order. SpaceX operates a Boeing 737-800. This is part of the Boeing 737 Next Generation series. This series was introduced in 1993 to replace the previous 737 aircraft. The 737-800 features a superior wing design, allowing it to store more fuel and support a greater maximum takeoff weight. This fearsome aircraft is powered by CFM International CFM56-7 engines that generate more than 27,000 pounds of thrust. Boeing also updated the aircraft's avionics and introduced additional cabin options. Here are the 737-800 specs. With a length of 129 feet 6 inches, a height of 41 feet 2 inches, and a wingspan of 112 feet 7 inches, the Boeing 737-800 can carry up to 189 passengers. Its maximum takeoff weight is 174,200 pounds. The cruise speed is 455 knots, with a range of 2,935 nautical miles. The aircraft has a service ceiling of 41,000 feet. SpaceX's second aircraft is a Gulfstream G450. According to JetSpy, this aircraft was first built in 2007 and is registered as N450GG. The registered owner is listed by the Federal Aviation Administration as TVPX Aircraft Solutions, an aircraft trust. However, according to JetSpy, the plane is being used by SpaceX. According to JetSpy, in 2024, the Gulfstream G450 registered as N450GG will have completed 150 flights, accumulating 150 flight hours. These flights used roughly 170,000 gallons of aviation fuel, causing 1,610 metric tons of carbon emissions. The three most popular airports visited by N450GG in 2024 are listed below. These include Draffen Miller Central Texas Regional Airport, Jack Northrop Field Hawthorne Municipal Airport, and Brownsville South Padre Island International Airport. This aircraft is an improved version of the Gulfstream 4, which was first constructed in the early 1980s. The original Gulfstream 4 had a stretched fuselage from the Gulfstream 3, new engines, and other upgrades. Its first prototype flew in September 1985, and it debuted in 1987. The Gulfstream 4 was substantially updated in 2004 with increased Rolls-Royce TE 611 8C engines producing over 14,000 lbs of thrust, a larger fuselage, the Honeywell Advanced Flight Deck Display Suite, improved flight controls, and new landing gear. This airplane can carry up to 19 passengers. It also measures 89 feet 4 inches in length and 25 feet 2 inches tall. It boasts a wingspan of 77 feet 10 inches. It had a maximum takeoff weight of 74,600 pounds, a top speed of 505 knots, a range of 4,350 nautical miles, and a service ceiling of 45,000 feet. What, if any, similarities exist between Elon Musk's freshly acquired aircraft and the United States' next-generation air fighter, the NGAD? The concept of a sixth-generation fighter jet represents the beginning of a new era in aerial warfare. These forthcoming aircraft, which will have improved abilities and cutting-edge technologies, are projected to revolutionize the game in air combat by improving air-to-air fighting skills and allowing them to reach heavily protected places. Several countries have recently announced ambitions to create their own sixth-generation fighter jets, demonstrating a worldwide push to modernize military aviation. The United States Air Force is a key player in the next-generation air dominance stealth fighter program. In 2013, DARPA Director Arati Prabhakar said that the United States has begun to investigate an air dominance effort. This sparked excitement among aviation aficionados worldwide, as the new aircraft was believed to have the most powerful engines, superior sensors, integrated artificial intelligence, and a swarm of drone wingmen. In 2016, the United States Air Force joined DARPA's research, announcing the Air Superiority 2030 initiative. The U.S. Air Force's next-generation air dominance program is an advanced project aimed at developing a new fleet of highly advanced aircraft. The primary goal is to develop a manned fighter plane known as the Penetrating Counter-Air Platform, which will be capable of breaking through heavily guarded airspace and confronting the most formidable adversaries. What makes the NGAD program even more exciting is that these manned fighters will be backed up by unmanned combat aircraft known as loyal wingman platforms. These autonomous aircraft will fly alongside the PCA and perform functions such as surveillance, electronic warfare, and direct combat, all while being commanded by the PCA's human pilot. The combination of manned and unmanned technology will result in a powerful and adaptable force capable of dealing with a wide range of combat scenarios. The NGAD program aims to completely alter air combat rather than simply developing a stronger fighter plane. The NGAD aircraft will be able to operate better in the future's harsh, contested airspace, thanks to modern technology such as artificial intelligence, cutting-edge sensors, and new engine systems. These advancements will provide the United States unparalleled control over the sky, securing aviation superiority for many years to come. One of the most notable aspects of the NGAD program is its emphasis on flexibility and quick updates. Unlike prior airplanes that took a long time to create and were difficult to upgrade, NGAD is intended to quickly incorporate new technology as they emerge. This means that the NGAD aircraft will remain at the forefront of military aviation, ready to respond to any new threats from adversaries. The idea for this program arose when the Defense Advanced Research Projects Agency investigated options for future air superiority systems for the U.S. Air Force and Navy aimed at the 2030s. After completing their Air Dominance Initiative study in March 2015, DARPA's findings prompted the establishment of the Aerospace Innovation Initiative in 2015. This effort attempted to create prototype X-planes to demonstrate next-generation fighter technologies. The NGAD program is also altering the way the Air Force obtains new aircraft. They're dividing the design, construction, and maintenance tasks and have allotted $9 billion to accomplish this. By 2025, the objective is to host more competitions and regularly test the ideas to verify their effectiveness. Although this project began with the goal of constructing a single type of plane, they now intend to develop a number of alternative systems. At the heart of this group is a manned fighter plane that is assisted by drones and computer technologies to improve its performance. The goal is to develop a system that will perform well in the Indo-Pacific region, where current Air Force aircraft lack sufficient range and power. They might even create two versions, one for the Indo-Pacific and one for nearby battlegrounds like Europe. When the American sixth-generation fighter was still in the concept stage, DARPA contemplated integrating the experience of U.S. Air Force and Navy professionals. However, it was quickly suggested that these branches train their warriors independently. According to rumors, DARPA sought to encourage amicable competition between the military. I'm hoping for two outstanding new generation fighters instead of one. As a result, The Air Force focused on building the NGAD while the Navy launched its own FX program. Despite many hypersonic and missile systems, stealth remains critical to the future success of the U.S. Air Force. Making the sixth generation even stealthier may be difficult considering the Raptor's near invisibility on enemy radars and the considerably more sophisticated stealth of the F-35 Lightning II. The F-22 has some of the most amazing stealth features, including a radar cross-section of 0.1 square meters, which appears as a little marble on enemy radar. However, the high cost of $350 million presents a disadvantage. NGAD specialists aim to provide advanced technology to the sixth generation while controlling expenditures to avoid burdening taxpayers. The U.S. Air Force estimates that the increased cost for the NGAD program will exceed $1.7 billion between fiscal years 2024 and 2027. According to Air Force Secretary Frank Kendall, each future fighter is estimated to cost several $100 million. For the time being, let's put financial worries aside and focus on the potential future attributes of this advanced aircraft. The next fighter plane is intended to have upgraded engines that are ready by 2025. Initially, they hope to create these new fighters fast, similar to the procedure utilized in the 1950S, but they've now taken a more traditional approach. The goal is to use these new fighters in the 2030s once there are enough. Some new technologies are being tried on existing aircraft, such as the F-22. Modern fighter engines work best at a particular position in the flight envelope. Sixth-generation fighters may include a variable cycle engine to improve efficiency at any speed and altitude. This design offers increased range, faster acceleration, and enhanced subsonic cruise efficiency. The engines will operate as turbojets at supersonic speeds and as high bypass turbofans at lower speeds. This capability is being developed by teams from General Electric XA-100 engine and Pratt & Whitney XA-101 engine as part of the U.S. Air Force's Adaptive Engine Transition Program. They intend to integrate these engines not only into NGAD aircraft, but also into the current F-35 fleet. For example, the Raptor is well known for its supercruise capability, which was a key requirement of the Advanced Tactical Fighter program that drove its development. However, supercruise uses a lot of fuel, therefore, it is frequently confined to short tactical bursts during missions. If supercruise could operate for longer periods of time without consuming too much fuel, it would significantly shorten travel time to and from mission zones. This poses a huge hurdle to the team building NGAD. The design of the new fighter will most likely stray from established norms, with a highly streamlined shape. With an elongated blended fuselage and wings lacking traditional horizontal and vertical stabilizers, this size layout prioritizes low observability across a wide radio frequency band to improve survivability while simultaneously enhancing aerodynamic efficiency. The fuselage materials will most likely feature enhanced stealth coatings to disguise the aircraft from infrared detection and reduce heat emission, as well as advanced thermal management technologies. Engineers must ensure that these stealth coatings are intact and do not require considerable maintenance after each flight, even at high speeds. Another important factor for the NGAD team will be the operating altitude of their next-generation aircraft. The F-22, for example, can fly above 60,000 feet, approaching the point where pilots require complete pressure suits. Missiles launched from such heights can go significantly greater distances than those fired from 20,000 feet below. Given the threat environment that JD will encounter, which includes space and spectrum warfare, it is apparent that the aircraft's versatility increases with altitude. Higher altitudes also provide a major line-of-sight advantage to fighter sensors and communication systems. At 40,000 feet, the line of sight is around 245 miles, but at 60,000 feet, it reaches 300 miles. This increased range is a strategic advantage. This is particularly true when navigating through intricate enemy air defense systems. Operating at those altitudes improves missile performance while also increasing the aircraft's overall situational awareness and effectiveness in combat settings. Like any other modern air fighter, NGAD fighters require continual data interchange with collaborative combat aircraft and other U.S. Air Force and Navy planes. As both a quarterback and a big hitter, the NGAD's communication range is critical. Every additional mile of connectivity increases the fighter's survivability, and widens its operational area without relying on beyond line of sight repeaters such as satellites. This brings us to one of the most significant sections, the armor. More than F-22 and F-35 missiles can be fitted to the NGAD. It will also include the cutting-edge A-26 Joint Advanced Tactical Missile, which is presently in development by Lockheed Martin. It will also have long-range engagement weaponry. Raytheon is creating these with its air-to-air missiles. For more than a decade, senior Pentagon officials have touted air-breathing hypersonic systems as the weapons of the future, making them a possible addition to the NGA's DS arsenal. Then there are weaponized lasers. The U.S. Air Force is already testing lasers with focal power ranging from 100 to 150 kilowatts as part of Lockheed Martin's laser advancements for next-generation compact environments program, and the Self-Protect High-Energy Laser Demonstrator, a collaboration between Northrop Grumman, Boeing, and Lockheed. It is entirely possible to use these lasers to protect NGAD fighters from incoming enemy missiles by blinding or destroying their homing systems. In June 2022, the U.S. Air Force decided that essential technologies were ready to support the program's next phase, known as engineering and manufacturing development. They tested a full-scale prototype of the NGAD fighter plane in 2020 as part of the AIX plane program, and by 2023, they had tested 3 prototypes. They publicly invited proposals in May 2023 with the goal of selecting a company to cooperate with by 2024. A Chinese state-backed tabloid has shown a tailless design for its upcoming 6th-generation aircraft. The design bears a striking resemblance to the ideas of the U.S. 6th-generation fighter jet. While the actual design of the U.S. 6th-generation fighter has not been revealed, the Chinese design closely resembles prototypes exhibited by U.S. weapons makers a few years ago. The Chinese tabloid Global Times linked to a video from the Aviation Industry Corporation of China that displayed this design. According to the newspaper, the tailless, fineless aircraft has a blended wing body shape. This provides increased lift, longer range, and lower fuel consumption. However, its most crucial attribute is its stealth capability. Vertical components such as tails and fins increase speed and maneuverability, while making the aircraft more detectable to radar. Protruding elements, such as fins, tails, and external weaponry, can be spotted by enemy radar because they reflect electromagnetic signals. Sharp edges and tails are easier for radar to detect than smooth aircraft, such as the B-2 bomber. This is why stealth aircraft, such as the 35, carry weaponry internally, while keeping the surface smooth to avoid radar detection. Despite its stealthy and aerodynamic shape, the new Chinese aircraft resembles U.S. prototypes from several years ago. Given concerns about China's attempts to duplicate U.S. weapon specifications through cyber espionage, this resemblance is surprising. The technological plans and systems for China's 6th-generation technology are not surprising. As depicted by the Global Times in 2020, they roughly resemble the F-35. According to the Chinese tabloid, the new PLA Air Force 6th-generation aircraft will include an autonomous computerized system that will collect, organize, and provide multiple information sources to pilots. Yang Wei, the J-20 designer, was described in a 2020 Global Times story as saying that a future fighter plane will need more range, better endurance, and stronger stealth. There are more air-to-air and air-to-surface weapons available, and they can provide pilots with precise battlefield intelligence and projections. This emphasis on providing pilots with clear and simple war zone intelligence is very similar to the F-35 sensor fusion, which incorporates data from 360-degree cameras, long-range targeting, navigation, threat warnings, and other elements such as speed, altitude, and angle of approach. They're combined, processed, merged, and displayed on a single screen for the pilot. China's vision for its next-generation fighters is very similar to that of the United States. According to the paper, an integrated system requires the aircraft to connect to a network, generate real-time situational images, create multiple attack routes, and share target information across mission areas in real time. Artificial intelligence is critical for early design and testing. The aircraft systems of U.S. 6th-generation stealth fighters will most likely incorporate new data sources such as electronic warfare, space radar warning signals, and unknown indicators. Advanced algorithms can rapidly scan large volumes of incoming data, compare it to a massive database, and make near real-time choices and calculations. This allows pilots to make faster and clearer decisions while lowering their mental effort. These are the primary aims of AI-driven programs, which is why they are being prioritized by the new generation of Chinese stealth aircraft. Conformal sensors incorporated into the aircraft's body, known as smart skins, are one example of an innovation that could be employed in sixth-generation fighters. Other elements described in the Chinese paper include new stealth designs, enhanced armaments such as lasers, adaptable engines, and the capacity to command drones.